Hello, welcome to this talk about our paper, Learning to Automate Chart Layout Configurations Using Crowdsourced Paired Comparison. My name is Aoyu, and this is a joint work from the Hong Kong University of Science and Technology and Microsoft Research. Our motivation: existing charting software or libraries such as Excel and Vegalite often use predefined heuristics to generate styles of charts which are often suboptimal. People need to repeatedly adjust different style parameters, which, however, is time-consuming and challenging, especially for those without design backgrounds. To address this problem, we aim to provide a machine learning approach to automate chart configurations by learning from human feedback. This requires collecting training dataset consisting of charts and human-given scores. However, humans often find it difficult to give an accurate score, and the scoring scales among different participants can be different that constrain the reliability of the resulting dataset. To address this problem, we ask participants to compare two charts and choose the one that they prefer. Comparison is relatively easier than scoring a single chart. To be more specific, we generate training datasets through crowdsourced paired comparison. First, we generate comparison pairs, which are charts encoding the same data but with different parameters. Then, we ask participants to choose a better one from a pair, and if all participants agree with each other, we mark the better chart as a positive and the other as negative. There is also a desk reject step where we mark charts violating a set of design rules as the negative in a pair. Thirdly, we train a machine learning model to learn human preference from paired comparison data. And finally, we propose two sampling strategies to improve the efficiency, and the details can be found in our paper. Here comes a machine learning model, which is a semi-structure that consists of two identical scoring networks working on the pair. The goal is to predict a higher score for the positive chart in the pair than the negative one. We evaluate our machine learning approach on two datasets collected from two experiments. In the first experiment, we have 3 parameters of a bar chart, and in the second experiment, we extend the parameter to 6. The results show that our method outperforms the baseline approach rank SVM and handcrafted fit matrix for layout qualities such as white space and scale. That said, handcrafted matrices are insufficient in capturing human preference. With a machine learning model now we could recommend chart configurations. In 2 user studies, we show that our method can at least achieve human-level performance and outperform the default styles in Excel and Vegalite and outperform the random configurations. We reflect on our implications. First, do not trust the default values. Psychological studies show that the default effect that humans can blindly trust the default values. However, default values are made to be acceptable but not best for all cases. Also, we discuss how to improve aesthetic quality of visualizations from a data-driven perspective, which is relatively under-researched in visualization recommendation system. Besides, we note the debate over what is beautiful is good. Aesthetic chart layout configurations might have negative influence over the perception that warrants future research. For more details, please refer to our paper, and all of our source code is made public in this GitHub.